In this lesson, we will discuss how to execute code based on a condition by using a case structure. In this section, we will talk about conditional logic. Conditional logic allows you to execute code based on a condition, which means if a particular condition is true, then do some action, else do some other action. For example, if the acquired temperature is greater than or equal to 100 degrees Celsius, then display a temperature has exceeded the maximum message, and also launch a warning pop-up dialog. Otherwise, display a temperature is in the normal range message instead. Let's take a look at a VI that implements this conditional logic. Notice if I run this VI and the temperature is greater than or equal to 100, the VI produces this warning dialog and this message. Now notice if I run this VI and the temperature is less than 100, I get a different message and no warning dialog. If we take a look at the code on the diagram, notice that it contains something new called a case structure. In this section, we will talk about creating and configuring case structures. When using a case structure, the first thing you should do is wire your condition to the selector input. The value the VI passes to the selector input determines which case to execute. The case selector label allows you to navigate through all the defined cases. You can place your code in the corresponding case. In this example, the greater than node passes a true or false value to the selector input of the case structure. If the selector input receives a true, then the case structure will execute the code in the true case. If the selector input receives a false, then the case structure will execute the code in the false case. The case structure adapts its cases based on the data type wired into its selector input. For example, if you wire a Boolean to the selector input, the case structure will contain a true case and a false case. If you wire an integer to the selector input, the cases can be either a single number, multiple numbers, range of numbers, or a default case. If you wire a string to the selector input, the cases will be strings. If you wire an enum to the selector input, the cases will consist of the enum items. If you wire an error wire to the selector input, you get a no error case and an error case. A case structure can also include tunnels. An input tunnel is available to all cases if needed. If you have an output tunnel, you must define the value the tunnel will output for every single case. If you have wired a value to the output tunnel in every case, the output tunnel will look filled. If there are one or more cases where the output tunnel is unwired, the output tunnel will look empty. You do also have the option to configure an output tunnel to automatically use the default value of its data type if it's unwired in a case. And then the tunnel will look partially filled. For example, if a tunnel is a numeric data type, then the default value is 0. To create a case structure, you want to go to this palette. Then you just click and drag to place it down. The first thing you want to do when you place down a case structure is you want to wire up your selector terminal to your condition. In this case, our condition is a Boolean. Now let's define what happens in the true case. For the true case, let's go ahead and put a one button dialog. So if the condition is true, let's display the following message. And now let's define the code for the false case. So let's go to the false case by going to our selector, choosing the false case. And I'm going to put down another one button dialog. So if the condition is false, we are going to execute and display a dialog saying this is the false case. Now let's go ahead and test this VI. And let's turn on highlight execution so we can see what happens. So here on my panel, I'm going to select on, which is true, and run. Notice that the true is passed and it executed the code in our true case, which is this dialog. And now let's try it with false. So I'm going to switch this to false, click run, and notice a false gets passed, and we also get the code executing in the false case, which displays a message saying this is the false case. Now let's use a case structure to execute code based on a numeric condition. So the first thing we want to do again is wire our condition, which is in this case is numeric, to our selector input. So notice that the case selector label has adapted from true and false into something numeric. So for example, now we have 0 and we have 1, and we also have a default case. So the default case will execute any numeric that is not defined by any of these cases. So right now, if the numeric passed in was a 3, we would actually go and execute the default case. Now for numerics, we have more than just 0 and 1, right? We can have the numbers 5, 10, 15, negative 20. So if we want to add more cases to our case structure, one way to do that is to right-click the case structure, go to Cases, and then Create Case After. So for this one, I could say I want this case to be 5, but I could also say I want this case to execute whether it's 5 or 10 or 15. So notice now that we have a case for 0, we have a case for 1, and we also have a case for 5, 10, or 15. So 5, 10, or 15 will execute the same case. And we still have our default case to capture all other integers. Let's go ahead and add another case. And say you want to add a range of numbers. So let's say we want everything from -1 to -infinity. So if I did that, I would do this. So now any number that's -1 or lower is going to execute this case. If I wanted to add another case for a range of numbers from 50 to 100, I could type 50 ... 100, and that would be a range. And if I wanted another case for everything 101 and greater, I can do that like this. So now notice we've got single numbers. We have a default case to capture anything that's not defined here. We have multiple numbers. We have ranges as well. Another way you can deal with case structures is you can select the case structure and add those cases and edit those cases in the Items tab. Now let's talk about how to use case structures with the enum condition. We'll also talk about how tunnels work as well. So for this example, our enum has items of add, subtract, multiply, and x squared. So let's go ahead and wire the enum condition up to our selector terminal as usual. And notice that the case selector label has adapted to the enum items. So now we have add and subtract here. Notice that we do have more items in the enum that are not in this case. So to add those, you can right-click the case structure, go to Cases, and notice there's an item specifically for Create Case for every value. This is something special for enums. So let me go ahead and select that. And now notice that we have a case for every single enum value. We have add, subtract, multiply, and x squared. Now let's explore how the tunnels work. So let me go to the add case, and what I want to do is I want to put an add node in there. So let me place that down. And let's create some tunnels. So now notice these are input tunnels because it is a way for us to input information into our cases. So we have X and we have input Y. And now let's create an output tunnel. So we're going to take those and we're going to send it to our output here. So notice that the output tunnel looks empty. And remember the reason for that is that this tunnel has not been defined in every single case. So if you look at the subtract case, for example, notice that in the subtract case, if we execute this case, we do not know what to output to this tunnel. So the output tunnel needs to have a value defined in every single case. So in the meantime, I'm going to fill this out. So now this is the last case that does not have anything wired to the output tunnel. Notice as soon as I wire something to the output tunnel, in every single case, the tunnel now appears filled. Also notice that it is okay if the input tunnels are not used in every case. In the x squared case, the input y is not used, and that's okay. The last thing to show with an output tunnel is if you wanted to use the default value if it's unwired in any case. To do this, you just right-click the tunnel and select Default if unwired. In this section, we will explore common examples of when you might use conditional logic. If you want to execute code based on user input, you can wire a control terminal to a case structure. In this example, if the user sets the triggering control to true, then the VI will execute the DACMX triggering node to set up this task to wait for a trigger. If the user sets the triggering control to false, then the VI will not execute the DACMX triggering node, so the task will not wait for a trigger. You can also execute code conditionally based on a measurement result. This example VI reads a waveform, extracts the maximum value, and checks if that maximum value is greater than a threshold. This result is wired to the selector input of the case structure. Now, if the waveform maximum is greater than the threshold, the case structure will display the waveform in the last exceeded acceleration graph. Otherwise, the case structure will do nothing. Let's run this VI. How would you modify this code to display a running total of the number of times the threshold has been exceeded since the VI started running? Use a shift register to store the number of times a condition occurs, and initialize that shift register to 0. If the condition occurs, read the current value of the left shift register, increment that value, and pass the value to the right shift register. If the condition does not occur, make sure to wire the left shift register through the false case to the right shift register, so that the current value of the shift register is still passed to the next iteration. You've completed this module. Here is a summary of what you've learned.